In this video, we're going to be testing a mean with a known sigma. In the first example, we have iron is essential to most life forms and to normal human physiology. It is an integral part of many proteins and enzymes that maintain good health. Recommendations for iron are provided in dietary reference intakes, developed by the Institute of Medicine of the National Academy of Sciences. The recommended dietary allowance, or RDA, of iron for adult females under the age of 51 is 18 milligrams per day. The following iron intakes in milligrams were obtained during a 24-hour period for 45 randomly selected adult females under 51. And then, at the 1% significance level, does the data suggest that adult females under the age of 51 are, on average, getting less than the RDA of 18 milligrams of iron? Assume that the population standard deviation is 4.2 milligrams, and it says note x bar is equal to 14.68. So they've calculated x bar for us, so we don't have to do that. And the important things to look at in this problem is that it says the population standard deviation is 4.2. So this tells us that we know sigma. And then we're also going to be interested in the 1% significance level, and less than is going to be important. That's going to tell us which tail test we're going to use. And our mu is going to be 18 milligrams. And then our x bar is here. So what I like to do is write all the information down that I'm going to need. So I'm going to need n, which is the total number selected, which was 45, and that was here. So 45 randomly selected. So we can say that n is equal to 45. X bar is equal to 14.68. Our significance level is equal to 0.01. Mu is equal to 18 milligrams. And then we're also going to need our sigma, our standard deviation, which was 4.2 milligrams. And now we want to work through our 5-step process. So we have a hypothesis test, so we're going to need to find our null hypothesis and our alternative hypothesis. So HO and H1. And I like to start with my alternative hypothesis because which-tailed test is told in the problem. So it was getting less than the RDA, so that means we're going to have a left-tailed test. So we're going to have mu is less than 18. And for our null hypothesis, we're going to have mu is greater than or equal to 18. The second thing we need to find is our critical value. So in this case, because sigma is known, we're using a z-test. So z crit is equal to. In order to find z crit, we could use our z-table, and we could also use our t-table, so it's a matter of preference. Now, I personally like to use the t-table, and I like to go to, we're doing one tail, so you can see the one tail, and we have a 0.01 significance level. And then if you go all the way down to the bottom where it says z, and some charts will say infinity, this is our z crit. So it's 2.326 right here. So we go back to our problem, and our z crit, now it was 2.326, but we're left-tailed, so it's going to be negative 2.326. And now we need to set up our rejection region. So we're going to say we're going to reject H naught if our z calc is less than negative 2.326. And now we need to find our z calc. So we have z calc is equal to x bar minus mu divided by sigma divided by the square root of n. And in our problem, x bar was 14.68, mu was 18, divided by sigma was 4.2, divided by the square root of 45. And when we put this in our calculator, we get negative 5.30. And the next step is to decide if we're going to reject our null hypothesis or we're going to fail to reject it. Well, here we said we were going to reject our null hypothesis if zcalc was less than negative 2.326, and our zcalc was negative 5.3. So we're going to reject h naught, and now we need to write a conclusion statement. And my conclusion for this problem is going to be, at the 1% significance level, our data provides sufficient evidence to conclude that adult females under the age of 51 are, on average, getting less than the RDA of 18 milligrams of iron. And you might also be asked to find a p-value. So if we wanted to find the p-value for this problem, we would say p-value is equal to, now we would use our zcalc and we would look it up on our z-chart. And as you can see, negative 5.3 is off the chart. So we can't find an exact p-value by hand unless you had a computer or a calculator. You're just going to be able to put that it's less than 0.0003 is the best that we can do with this table. So we go back to our problem and we would say, instead of p-value equal to, p-value is less than 0.000, 3 zeros and a 3. So 3. And this p-value also helps verify that our data was significant. Our significance level was equal to 0.01, and if your p-value is less than your significance value, then the data is significant. And less than 0.0003 is less than 0.01. So it verifies our hypothesis test. And that's all for this video on testing a mean with a known sigma.